Hello, everybody. Due to the coronavirus, the AP Calculus exam has been modified. If the exam were on all of the topics that they traditionally are, I think we'd be in really good shape. One of the hardest things to do now is to decide what not to study and what to study as we prepare for this two-question exam. One of the easiest modifications is that polar, parametric, and vector calculus are out. In my course, I call this Q403. In our book, it is chapter 10. It is the last unit that we did for the year. It is also the test that we never took because of the quarantine. So that's pretty easy to eliminate that. The College Board calls this polar parametric vector unit, they call it Unit 9. Unit 9 is out. The hardest thing to determine what is on the exam comes from the sequences and series unit. In my course, I call this Q401, Q402, which corresponds to our textbook, Chapter 9A and Chapter 9B. The College Board calls this Unit 10. Now, the major point of this video is to go through this Unit 10 and talk about what is and what is not on the AP exam, what you should focus your time and attention on. Here is page 1 of 2 that discuss the different topics in the sequence and series unit. So let's just kind of go through this. 10.1, they say, is out. That's defining what it means to be convergent and divergent. That deals with partial sums. We didn't really focus much on that anyway. Section 10.2, working with geometric series. That is in. The nth term test for divergence, that is out. The integral test for convergence, that is out. Harmonic series and p-series, that is in. Comparison test for divergence, like basic comparison test, limit comparison test, is out. The alternating series test for convergence, that is in. Ratio test for convergence, that is in. Determining absolute or conditional convergence, that is out. And alternating series error bound, that is out. That's what we would have called E1. Now, before I move on to page 2, I want to tell you what my intuition was about this, at least initially. So if I'm trying to find a geometric series converging or diverging, harmonic series, alternating series, or ratio test, my initial gut was an interval of convergence, and then any one of the first 3 items can be used to test the endpoints of the interval. And I also picked out in the review assessment number 6 some of the items that would be consistent with that initial intuition. Now let's look at page 2. This is the final page of the topics. I'm going to work backwards here. 10.15, representing functions as a power series. That is out. 10.14, finding a Taylor or Maclaurin series for a function. That is out. Now, when I read that initially, I said, all right, so Taylor series, Maclaurin series, they're out. The focus is going to be on, whether or not a function converges or diverges, using some of the basic p-series, alternating harmonic, alternating series test, etc. Error bound here is out. And then this says radius and interval of convergence is out. So looks like you won't be finding an interval of convergence. Bummer. I really thought you would. And now this is the one that's causing me the most confusion. So a Taylor series and a Maclaurin series for a function is out, but this one says, and this one's in, finding a Taylor polynomial approximation of functions. So then my mind started going, wait a minute. If you're going to find a Taylor polynomial approximation, that is basically the same as finding a Taylor series, which really incorporates the following. So if you recall that f of x is equal to f of 0 plus f prime of 0 x plus f double prime of 0 x squared over 2 factorial plus f triple prime of 0 x cubed over 3 factorial plus dot dot dot. We use that to find power series, but we also use that to find a Taylor polynomial. So suppose I wanted a third degree Taylor polynomial, I would still have to find f of 0, f prime of 0, f double prime of 0, and f triple prime of 0. And so the raw construction feature that we talked about in class looks like that is in. That is something you should know. Below here, I'm going to write the Taylor polynomial centered at a. So it's f of a plus f prime of a x minus a plus f double prime of a x minus a to the power of 2 over 2 factorial. And I think you get the idea. I'll put one last one just so I feel accomplished. Finding these values in a raw construction sense would be valuable to construct a Taylor polynomial approximation. So I am shifting the focus here. I now believe that you will be asked to find a Taylor polynomial. And the reason I think you'll have to do that is if I have to find f of 2, and I have to find f prime of 2, and I have to find f double prime of 2, let's say, I'm trying to approximate a function using a second degree Taylor polynomial, which would be f of 2 plus etc. There are a ton of calculus efforts that we can use to find this. So suppose I'm given a derivative equation, I can use the derivative equation to find this. And then maybe I have to take the derivative of the derivative to find this. That can incorporate implicit differentiation. There are also clever ways that I have seen and I have created that really can make this a good hybrid question, and the trick is to find all of these values. So one example, and I'm going to send some of these questions that I've created and or seen so that you can put it all together. I really feel strongly now that this is the type of question you're going to see on the AP exam. And when I send these questions, you'll see what I mean. But I'm just going to give you a forecast. So suppose we have g of x equals the integral from 2 to x of f of t dt. This is the fundamental theorem of calculus part 1. So g prime of x is equal to f of x. That was the takeaway there. So suppose I was coming up with a Taylor polynomial for g, let's say centered at 2. Well, then g of 2 would be the integral from 2 to 2, and that would equal 0. And then g prime of 2 would equal f of 2, and that would be some value determined by a graph or a formula. And then if I have to find g double prime of 2, well, that could equal f prime of 2, so maybe the slope of the f graph would give us that value, and then we could incorporate those into our polynomial construction and go from there. Here is another kind of simple example that I was thinking. So we have a differential equation where y is equal to f of x, and then we have some condition that f of 2 is equal to 1. And then if I'm coming up with a approximation for f of x using the Taylor polynomial construction, then I can use this information here. So f of 2, let me just write this, f of 2 is equal to 1 because it's given. Now I need to find f prime of 2, which is really equal to f prime of 2 comma 1, and so I'll plug that into my derivative equation, and 2 plus 1 is equal to 3. So we come over here and I'll say plus 3 times x minus 2. Let's do the second derivative. And the second derivative, as you recall, is the derivative of the derivative. And so that's going to be the derivative of x plus y. the derivative of x is 1, but the derivative of y is dy dx. Implicit differentiation. And so now f double prime of 2 is really f double prime at x equals 2, y equals 1, and dy dx is equal to 3. So then this becomes 1 plus 3, which equals 4. And so I add that, 4x minus 2 to the power of 2 over 2 factorial. In the event they want to approximate f at 2.3, well, that's going to be approximately 1 plus 3 times 0.3 plus 4, 0.3 squared over 2 factorial, and that can be left alone. So I'm thinking this would be a good thing to ask on the AP exam because it incorporates several items. So definitely remember the raw construction for a Taylor polynomial. So that is the end of video 1. I think it's an important video. Basically everything else we've learned is in, but I am going to create some other questions and create a couple videos to really zero in. I think we can do this. I really feel strongly that if you've been keeping up with your work, put an honest effort in all the solo questions, all the review assessments, even if we studied a little bit more than we needed, then I think you're going to be in really good shape. It's better to study a little bit more than not enough. So I want to make sure to give you some questions to really focus in on this sequence and series part as relates to all the other topics.